So in this example, we are going to go over how negative exponents affect fractions. So let's look at it aside. If we're given a over b to the negative, let's say, p, that will equal b over a to the p, which will equal b to the p over a to the p. So let's use that. So first thing we want to do is flip negative exponents, make them positive. So now we have 7/5 squared plus 8/3 to the 1. Because we flipped both of the exponents. Now we want to multiply through the exponents. Which will equal 7 squared, which is 49, over 5 squared, which is 25, plus 8/3. And now we're back to simple adding. If you look back at the previous example, I went over the rule for adding fractions. You need the same denominator. So one easy way to find the same denominator without using LCMs, GCFs, and all of that is to simply go 49 25ths times 3 over 3 plus 8/3 times 25 over 25. Sorry, again. I'm just gonna times 25 over 25. And why did I choose those two numbers to multiply by? Well, it's because the 3 is here and the 25 is over there. So by multiplying them by the both, they now have the same common denominator. Or 49 times 3 plus 8 times 25 all over 25 times 3. Which equals 49 times 3 plus 25 times 7. So 49 times 3 is 147 plus 8 times 25, which would be 200, over 3 times 25, which is 75. So now we can add the numerator together. 147 plus 200, which will equal 347 over 75. And now, last thing you can possibly do is to reduce the fraction. Since now we have just one fraction with one numerator and one denominator, it's easy to do. And now we check using our divisibility rules. Let's think. We could look at the 75 because that would be an easier one to reduce than the 347. So 75 divisible by 2, no. Divisible by 3, 7 plus 5 is 12, yes. 3 plus 4 is 7, plus 7 is 14, so no, that's not the numerator is not divisible by 3. Divisible by 4, no. Divisible by 5, yes, but the numerator isn't. Divisible by 6, no. Divisible by 8, no. Divisible by 9, no. Divisible by 10, no. So therefore it cannot be reduced.